Hello SS1, good to see you again after a while. Welcome again to our biology online class where we teach from video, okay? And I hope you've been seeing these videos, I trust. And also I've given you notes on the topic I'll be discussing right now, which is relevance of biology to agriculture. And I'm sure you have downloaded the note I sent earlier on this topic. Okay, so delving in straight away, we'll be talking about relevance of biology to agriculture. Now, you know that biology and agriculture are kind of related, right? Because biology has to do with the study of living things, which are plants and animals, isn't it? Okay, remember bios, living organisms, plants and animals, okay, and other forms of life, okay, which can share plant and animal similarities, okay. But when we talk about agriculture, it has to do with the planting of crops and rearing of animals for man's use. So you see, plants, animals for man's use, plants, animals. So plants, animals, of course, they are bios. So that's why there's relationship between biology and agriculture. We're talking about relevance of biology to agriculture. In fact, looking at it broader, you just see that biology, okay, without biology, there will be no agriculture, so to say, because agriculture will have to use these life forms, plants and animals, okay, right, isn't it? Agriculture is all about plants and animals, and biology is the study of plants and animals. So you see the relationship now, okay. So even though they are related, okay, and we will not be discussing every relevance, okay, we will be directed, okay, we've been directed from your curriculum, okay, of the class, from Nigerian curriculum for your class, okay, which was a group that just mapped out, of the Ministry of Education, of course, that mapped out the scheme of work, okay. The scheme of work states that you should at least know these objectives. So we'll be looking at the objectives that you should know within the relevance of biology to agriculture, okay? We won't just be discussing aimlessly. We've been guided on what should be the objectives for this topic. So the first one should just be that you know the classification of plants. So looking into that, we'll be discussing under this topic, relevance of biology to agriculture, we'll be seeing the objectives of you knowing how plants can be classified, okay? So talking about classification of plants, plants can be classified based on botanical classification, can be classified based on what? Agricultural classification, can be classified based on life cycle and even life forms. And there's an additional one I would just add, classification based on the number of cotyledons. I know in the note I gave you 4, but let's just add this 5th one, classification based on number of cotyledons. So it can be up to 5, not just 4, as I gave you earlier in the note. Now, talking about botanical classification, of course we said, and in the note you saw, and I trust you have downloaded the notes and you have at least seen it before this discussion, because I gave it to you earlier on, and if you've not done that, make sure to download, please, okay, and look into it after this discussion. Now, talking about classification of agriculture, botanical classification of plants, all right, which is a major way of classifying plants. You see that plants can be classified into the divisions. Now, plants belongs to the kingdom Plantae. I hope you still remember the taxonomy. Plants belong to the kingdom what? Plantae. All right, not plantain, like Plantae. I hope you remember it's ending with AE. All right, okay. So, and then of course, the divisions under this kingdom Plantae, okay, based on classification based on botanical means will be the division Schizophyta, the division Bryophyta, division Talophyta, the division Spermatophyta, which can be subdivided into your gymnosperms and your angiosperms. I hope you remember all these terms. Remember, we did it first term in your SS1. I hope you've not thrown away your notebooks. All right, we did this earlier, you should know them, isn't it? Now somebody may ask, what's with all this fighter? Now fighter, that suffix fighter is just meaning plants, okay? It's related to plants. So fighter means plants. All right, so what organisms fall into these divisions, okay? So we'll talk about the division Schizophyta that embraces the monerans or the bacteria. Okay, then we'll talk about the kingdom Talophyta. All right, that would be the algae and the fungi. Okay, when we'll talk about the kingdom Bryophyta, that would be the liverworts, the mosses. When we'll talk about the kingdom the division Pteridophyta. I hope I've not been saying kingdom since. So division Schizophyta, we said monerans, isn't it? Division number 2, division Bryophyta, the liverworts and the mosses. Division what? Talophyta will be the algae and the fungi. The division Pteridophyta will be the ferns. Okay, and then the division Spermatophyta will be your angiosperms and your gymnosperms. Spermatophyta are your seed-bearing plants, and your angiosperms are flowering plants. You remember? So I will repeat again that under this botanical classification, okay, of the kingdom Plantae, okay, of plants, we have divisions. Okay, the first division, we have the division Schizophyta, which embraces, or examples of organisms under this division Schizophyta will be the bacteria or the monerans. The division Bryophyta, that will be the liverworts and the mosses. Okay, then division what? Talophyta, that will be the algae, the fungi. Division Pteridophyta will be the ferns. Division Spermatophyta, okay, has 2 subdivisions, which are your gymnosperms and your angiosperms. Okay, so they are your seed-bearing plants. Okay, and you know that your angiosperms are your flowering plants. So flowering plants fall under the subdivision, okay, angiospermae, which falls under the division Spermatophyta. All right. Now, I hope you will be able to recall all of this. So that's just basically what the botanical classification. So all plants in the world can be classified based on botanical classifications into these groups that have just been mentioned. Okay, there were about 5 of them. The first one Schizophyta, second one Bryophyta, third one Talophyta, fourth one Pteridophyta, fifth one Spermatophyta. And the Spermatophyta has 2 subdivisions of gymnosperms and angiosperms. Okay, all right. So that's a way of classifying all plants in the world. Okay, that all plants in the world must fall into any of these groups. Remember, biologists, okay, and even scientists, they classify, they group organisms based on certain relatedness that they share. So all plants in this world can come into any of these groups that have just been mentioned. Okay, all right. Now, excuse me, another way of classifying plants, all right, aside botanical classification, because we are looking at all options, all possible options of classifying all the plants in the world. Now, if you don't want to classify all the plants based on botanical classification, okay, another way will be based on agricultural classification. Okay, so here we have lots. We'll have the legumes, the cereals. Before we delve into that, I hope you still remember what those organisms I just discussed under those divisions, like your liverworts, mosses. We drew many of these diagrams when you were in first term. I hope you still remember what they appear like. Okay, if you do, well done. Okay, let's fast forward to where we were. So talking about agricultural classification, okay, we can classify all plants in the world into any of these groups, okay, of legumes or beverages or cereals or nuts or forage crops or spice crops or stimulants or beverage crops or fruit crops or vegetables, you see that, or oil crops. So all crops in the world can fall into any of these groups. Okay, they can be maybe cereals, or if not, maybe they are legumes, or if not, maybe they are oil crops, or if not, maybe they are forage crops, or if not, maybe they are lettuce crops, or if not, maybe they are nuts, or if not, maybe they are stimulant crops, or if not, maybe they are roots and tubers crops, or if not, maybe they are vegetables crops. Okay, things like that. So we have legumes, cereals, roots and tubers, fruit crops, beverage crops, oil crops, lettuce, fiber, spice crops, stimulant crops, forage crops. All these are classification of plants based on agriculture. And in terms of agricultural classification, biologists or agriculturalists, okay, have decided to classify all these things. Okay, maybe that's based on the importance, maybe economic importance or the use of crops. Okay, based on, now classifying crops based on agricultural classification, it is with the reasoning of the nutrients, okay, the food material or the food substance contained in that food crop. Okay, and it can also be based on the economic usage or importance that the crops play. All right, so this is the idea of classifying plants based on these groups. All right, so that's another way of classifying plants. And I hope you know examples of legumes. For example, legumes are rich in proteins. Of course, you know, okay, they are very rich in proteins. Examples would be your cowpea, your groundnuts, okay, your peas, your soya bean, your beans, okay. All right, so your peas, beans, groundnuts, they are very rich in proteins and they are legumes. An example of, what about cereals? Now, cereals are normally seed crops, okay, and they are very rich in carbohydrates, okay. And examples will be the maize, rice, guinea corn, millets. All right, then what about roots and tubers? Okay, they have carbohydrates or starch stored in the roots or stems or tubers, okay, of this root and tuber crops. Okay, you find out that the stems of this root and tuber crops, okay, are fattened, okay, to contain starchy food substances. Okay, and examples of course would be your yam, your cocoa yam. In the note I remember I spelled it C-O-C-O-A. Please correct it, remove the A. It's C-O-C-O, yam. All right, so cocoa yam, all right, would be an example. Your potatoes, whether Irish or sweet potatoes, okay, they are all your tuber crops, okay, and so on and so forth. And then what about vegetables? Of course, vegetables are leafy. Okay, sometimes they can come, you know, they are leafy, and they are rich in vitamins and minerals, okay, and they can be used for, yeah. So examples of vegetables, of course, your pumpkins, okay, your pumpkin leaves of vegetables, your, what else? Green, that is your amaranthus species, okay, that will be your green, okay. Then all the vegetables you can think of, even your onions. You know that onions, of course, you see that they are leafy but formed into bulb. So your onion falls as vegetable, okay. Your tomato, even your okra, okay, even though it's having seeds, one could also, it can fall as maybe on the fruits too. It's having seeds. That one is, let's classify that one as fruit because it's having seed inside. All right. So, but most leafy vegetables that we use in cooking, that one, those ones fall into vegetables. Examples would be even your scent leaves, okay, your bitter leaves, your pumpkin leaves, your ugu, your green amaranthus, okay, your what else? So many, all of them, okay, that we can use to cook. Okay, they are leafy in nature. Most of them they are leafy in nature. Okay, and then what about your fruit crops? They are also rich in minerals and vitamins, and they contain seeds inside, which can be edible and sometimes may not also be edible, but you plant the seeds to get the fruits later. All right, so we have lots of fruits, right? Oranges, pineapples, banana, mangoes, what else? Apples, what else? And so on and so forth. There's so many fruits in the world, okay? Your pawpaw and all that, your guava. All right, what about beverage crops? These are crops that can be planted for drinks, okay? And they can be processed, and the liquid coming out, okay, can be used to make a lot of nice, refreshing drinks. All right, examples would be the cocoa, the coffee, the tea, okay? Your cocoa crop can be used, is a beverage crop. And then what about your oil crops? Of course, they are rich in oil, as the name implies, okay? Oil can be squeezed out of it, processed out of it, and used to make delicacies, okay? Example would be your oil palm, your groundnut, your cotton, your cocoa nut. These are some of the crops. Then what about the lattice crops, okay? Lattice crops, you discover that liquid called lattice, okay, gushes out of such crops, and this liquid or lattice can be used to produce plastics or your rubber materials, okay? So your lattice crops. Example would be your rubber crop, okay, your rubber, and so on and so forth. There are so many of them. Then your fiber crops, okay, you have can be used, cotton jute, for example, can be used to make thread-like materials or fiber for the textile industry. Then your spice crops, okay, they are spicy, okay. These crops can be used to spicing up, okay, our food, okay, to add flavor to our food, okay. Examples would be the ginger, your pepper, your onion, your thyme, your curry, your turmeric, your so on and so forth. Okay, used to spice, even pepper, right? I mentioned it earlier, okay. So give more flavor to the plants, to the food. All right. Then what about stimulants? These are crops grown for medical purposes, okay, which will be used for making medicines for healing purposes, okay. So it's very important to the healing world, the stimulant crops, okay. Examples would be the cocaine, the cola, the lime, the Indian hemp, the marijuana, okay. It's spelled marijuana, J, but it's pronounced marijuana. Okay, so these are actually, if abused, okay, they most times can be abused, okay. Something called drug abuse, okay. These stimulant crops can be abused, okay, leading one to drug abuse, which can cause madness, which can cause untimely death, okay. So marijuana, they are not bad, okay. They can be properly managed, or the right dose or size can be actually harvested and used to process good medicines like chloroquine for us, and that we use for treatments, okay. But the problem is that people normally abuse these drugs, even nicotine, okay. People normally abuse these drugs, okay, and it causes a lot of issues for them, can lead them to have psychological problems, and they may die off. All right, so they are not meant to be abused, okay. In some parts of the world, okay, you discover that they could have marijuana farmland, like a large piece of land where marijuana is all over the place grown, but it's not for anyone to go and start abusing them. No, they are grown so that they can be processed into medicines, okay, for the health benefit of the population, okay. But the problem is that people will go ahead to abuse these crops. It shouldn't be. So these stimulant crops themselves are not bad, okay. They are very useful for making vital medicines such as your chloroquine for treatment. However, the problem is that people normally abuse these crops or whatever they are processed into, which shouldn't be the case. All right. Now, what about forage crops? These are crops that are just grown for feeding farm animals. All right. Example would be the Guinea grass, the elephant grass, the Gambia grass. Okay. They are just grown, okay, for the purpose of pasture or providing food for grazing by the farm animals. Now, what about nuts? Okay, nuts, they have shells, but inside are edible seeds, so to say. Okay, so when you crack the nuts, you can find an edible seed inside that it's more succulent. So examples of nuts will be, nut crops will include the coconut, the cashew nuts, the oil palm nuts. So on your own, just read them up and refer to your textbook on this topic for more information. All right, but this just basically any crop in the world can belong to any of this group, any plant crop. So that's another way of classifying plants. Okay, so another way of classifying plants would be on the life cycle. Okay, so if you don't want to classify plants based on botanical classification or agricultural classification, you can go ahead to classify plants based on the life cycle. So the third way would be classification of plants based on life cycle. Now we'll talk about this one. We have three divisions. We have the annuals, biennials, and the perennials. Now we'll talk about the annual crops. Okay, these are crops that their lifespan is just within a year, 1 year, not more than a year. Okay, that means they would have grown, matured, reproduced, completed their life cycle, and even die within a year. All right, so that is just it. So they survive for a year. All right, so that's why they are annual. Annual has to do with yearly. All right, so examples of annual crops would be maize, yam, groundnut, rice, beans, millet. All right, now we'll talk about this. So those are examples. Now we'll talk about biennial crops. Okay, we have another one, biennials or biennial crops. Now we'll talk about the biennials. They are, okay, their life cycle is completed within 2 years. Now the first year will just be for them to grow, okay, and mature. But the second year will now be for them to reproduce. Okay, so within 2 years they have completed their life cycle, and then they die off. So their survival is within 2 years. They live for 2 years, and at the end they will die within the 2 years. Okay, they can't stay up to 3 years. They can't reproduce in the third year. No, it's they last for 2 years. Okay, so by the first year they just grow, they mature. The second year they would have reproduced and die off. So examples of such biennial crops would be your pineapple crops, cocoyam crops, your cassava crops, your plantain crops, your sugar beet crops. Now the sugar beets are just like the sugar cane. Okay, they are also rich in sugar. Okay, the difference is that the sugar cane is longer, like a stick, right? But the sugar beet is coming as if it's in the form of tuber or potatoes. You see the way, you remember the way the cocoyams or the potatoes are in tuber forms. They come in tuber forms. Okay, but they are just they store lots of sugar. They can also be processed, and sugar can be gotten from them, just as you can get your sugar from the sugar cane. All right, what about the perennial crops? Okay, so if we have the 1 year, 2 years, we also have 3 years, and these are the perennial crops. Okay, they last for more than 2 years. They can last for 3 years or even more. Okay, so the perennial crops will last for 3 years or even more than 3 years. Okay, but they last far more than 2 years. Okay, they can last for 3 years or even more than 3 years. Okay, so they reproduce, they grow, they mature, they reproduce, and they die. Okay, in 3 years or more. okay, not less than 3 years. So they last longer. Examples would be your cocoa plants, your rubber plants, your mango plants, your oil palm, orange trees or plants. You see that they last long. Okay, it takes a longer time for them to grow, it takes a longer time for them to mature, it takes a longer time for them to reproduce and complete their life cycle, and then they die. So when we talk about life cycle, it's all about the beginning and the end of life. That's life cycle. Okay, so when we talk about life cycle, you just have to know that it has to do with when that organism was born and when it died. So from birth to death, that span is life cycle or lifespan. Okay, so what we're saying is that annuals, they have a lifespan of 1 year. Okay, then not more than a year. Then biennials, they have a lifespan of 2 years, not more than 2 years. Then perennials, they have lifespan of what? 3 years or more. So it can even be 4 years, can even be 5 years. But whether it's 3 years, 4 years, 5 years, 10 years, you classify all of them as perennials. Okay. Okay. So another way of, so by this we have done justice to classification based on lifespan or life cycle. Okay. Now let's talk about classification based on life form. That's another way of classifying plants. If you don't want to classify plants based on the other three, you can choose to do that based on life form. And that will be into three major ones as herbs, shrubs, or trees. So herbal crops, they grow few centimeters above the ground. So they are really short, just a few centimeters. Okay, not that they have not matured or cannot reproduce or they are still growing. No, they have reached their natural height, even as adults, and they can reproduce within that height. But their length is not up to a meter. So it's just few centimeters above the ground, whether that's their mature or the highest height they can attain. Then talking about shrubs, they grow less than 2 meters above the ground. Okay, so shrubs, they can grow more than centimeters, okay, more than the herbs, but they will not grow up to 2 meters. So they are quite taller than the herbs, the shrubs. Okay, so you have the herbs, you have the shrubs. The shrubs are higher, but they are still less than 2 meters. Okay, now I want to talk about the trees. They grow many meters. They can be 2 meters, 3 meters, okay, 4 meters, higher meters, even 6 meters, taller. Okay, we have very tall trees. For example, the Iroko tree. Wow, that's a very tall tree. More than 5 meters, very high. More than 6 meters. It can be very tall. Okay, it can grow that tall, more than 6 meters above the ground. That's why it's a very tall tree, the Iroko tree. That's why we use this, what they call it? Is it, as tall as the Iroko tree? Is that what the metaphor is, simile? I don't know. Find out. Okay, but I know we have as tall as what? Iroko tree. Isn't it? I think that's simile, right? Okay, anyway, we are not doing literature. All right. Okay, let's then move on to what? What's the next one? Okay, so we're through with based on life form. Okay, whereby we classify plants as what? Based on life forms: shrubs, herbs, trees. So the herbs are the shortest, followed by the shrubs, and then the tallest will be the trees. Okay, let's move on to another way I just introduced. Okay, I didn't give it in the notes, but you could just add it. There's a fifth way, okay, that I want to add for you. Okay, that would be classification based on the number of cotyledons or seed leaves. So plants can be classified either into monocotyledonous plants or dicotyledonous plants. Okay, so plant crops can be classified as monocotyledons or dicotyledons. Monocotyledonous plant crops or dicotyledonous plant crops. I know that you are familiar with these terms already, okay? I just felt like shipping them in to be a fifth way of classifying plants, okay? So based on number of seed leaves. Examples of your monocots, for short of monocotyledons, will be your maize, and examples for dicotyledons will be your what? Groundnuts. Okay, so another dicotyledon can also be your bean. Okay. But example of monocotyledons will be your maize. Okay, dicotyledon, your groundnuts, your bean, or your cowpea. All right, so that's that for that. Let's forge ahead. So we are through with the first objectives, or the first objective of the objectives of this topic, and that's the one we just finished, which is classification of plants. So you have seen that we can classify plants into 5 ways: as classification based on botanical classification, based on number 2, agricultural classification, based on lifespan or life cycle, based on life forms, based on number of cotyledons. So with that, we are through with the first objective. So the second objective will be for us to talk about what's the next one? Let me see. Oh, what was the next one? Can you remember me? Can you remember for me? All right, let's talk about never mind. Okay, let's talk about farming practice. I know we talked about shifting cultivation. There are many farming practices in agriculture, isn't it, that will help the soil to regain its lost nutrients. And I made mention of shifting cultivation is a way, but there's this one I really want to explain, which is the crop rotation practice. Now, looking at this table, we'll talk about crop rotation practice, agricultural practice. Now, this is a system of farming where the crops planted are rotated systematically. Why? For the reason of improving the fertility of the soil regaining nutrients. So what the farmer, giving you an example of a 4-year crop rotation course, as you see in the table. Now, on a piece of land, what the farmer just did was to section his piece of land into 4 sections, 4 parts. And looking from the table, okay, he made it into part 1, part 2, part 3, part 4, or plot 1, plot 2, plot 3, plot 4, but on the same piece of land. It's just that he sectioned his piece of land, his arable piece of land, okay, that's his farming land, farmland. Now, what he did was that the first year, okay, now we're talking about crop rotation. It's all about alternating on a yearly basis, so to say. Maybe on the first year, okay, after segmenting his farmland, he planted on the first plot or part, he planted cassava. And then on the second part, he planted guinea corn, as you can see in the picture, right? I'm just giving you a 4-year crop rotation course. And then the third, he planted yam. The fourth, he planted soya bean. For the year, this was his order of planting. And even though he harvested, he replanted like this. Okay, he maintained cassava on farmland 1. So that when you go to the first part of the farmland, is always cassava for that year, and so on and so forth. But coming into year 2, instead of maybe the farmer, instead of this is very important, because the farmer may not have much money like that or resources or to have many plots of land everywhere to plant as he pleases. So he decided that this one he has, let him be able to plant varieties. However, let it be in such a way that the soil will not be depleted of nutrients. So the second year he alternated. On the first plot he no longer planted cassava, but he planted what he planted in part 2, which is guinea corn. He rotated it. So guinea corn, he didn't plant it again in the plot 2, but he planted it in plot 1. That was the second year. And then yam from 3 to 2. You see now? Soya bean from 4 to 3. And then the last part, he planted what he planted the first plot, which was cassavas. So you see. Are you seeing it? All right. So year 3. So this was just the order for the whole year. So that anytime you went to part 3 or plot 3 of the land, it's always soya bean you see for that year all through. Whether he harvested, he planted soya bean again, and it was just soya bean. Now, talking about the third year, you see what he planted in plot 2, he then moved it to plot 1. What he planted in plot 3 to plot 2, plot 4 to plot 3, and then 1 to 4. That was the order for the third year. Then the fourth year, what he planted in plot 2, he planted in plot 1. What he planted in plot 3 of the previous year, he planted in plot 2. What he planted in plot 4 previous year, he brought it to 3, and then 1 to the fourth year. Fourth plot. Can you see the order? So it's going diagonally. You see that diagonally, the same kind of crop. So you know how to make a 4-year crop rotation course following this pattern. But it forms as if it's going in diagonal. That's the pattern. Slanting. Have you noticed? Then the first one will become the last one of the succeeding year. You see that? Good. Somebody will ask why. Okay, the first reason is that the farmer is trying to maximize his piece of land. All right. However, the thing is, if he kept planting cassava year in, year out on plot 1, if he kept, for example, if he just planted cassava, guinea corn, yam, soya bean for like 4 years straight, that way on the same plot of land, nutrients will be depleted. Okay. But soya bean, for example, or legumes that you can see, they have a way of replenishing the lost nutrients. They have a way of, fixing nitrogen into the soil. Because their root nodules, okay, can harbor nitrogen fixing bacteria, which can fix nitrogenous, okay, which can convert nitrogenous gas into nitrates, enriching the soil with nitrates, okay, which is a macronutrient element that for, okay, the photosynthesis to take place. Okay, so it's very important. Nitrates are very important in the soil. Okay, so this soya bean can help replenish the soil with nitrates. Okay, because they are legumes. Okay, and other protein requirements. Okay, because that nitrate can be used for protein synthesis. Okay, so when plants has the right quantity of nitrate, which is of nitrates, okay, which contains nitrogen, which is a macronutrient element, you see that that plant can undergo protein synthesis. It will be enriched with protein. And when the leaves of such plant, for example, falls to the soil, it can replenish the soil, add humus content to the soil, enrich it again. All right? So nitrogen is very, very important. So that's the role legumes play. They add nitrates or nitrogen to the soil, enriching the soil with nitrates. And any plant that will subsequently be planted on that piece of land will derive nitrogen for protein synthesis or making of more food. So that way, you see that in crop rotation, there's always a combination, okay? It's always involving legumes. And in this case, we have soya bean. It's not just there for play. It's to help enrich the soil. So that's why it's very, very important to alternate, because with all these legumes, because they will play a role in what? Replenishing the soil with nitrates so that protein synthesis can occur by the plants that will subsequently be planted there. So you see that the soya bean has replenished each portion step by step. So every soya bean he plants has a way of enriching the soil. But assuming it's just planted straight away the way he did in first year all through the 4 years, that means only soil 4 will be rich with nitrogen. The rest, plots 1 to 3, will be lacking in nitrogen. And what you have is that the crop you're planting on 1 to 3 will not grow well. They will not reproduce well. There will be shortage of food. There will be depletion of nutrients, and so food will not be well produced. The yield will be very low. Okay, so it's for the purpose of maximizing his piece of land, yet, okay, not depleting the soil nutrients, yet conserving the nutrients of the soil for greater yield, and thereby we having more food. Okay, so that is just what I wanted to show you. Then another one we're talking about aside this crop rotation is that aside this farming practice that we just talked about. Okay, the next one is that another objective of your scheme of work is that you know food preservation and storage. Okay, you should know food preservation and storage. How can we preserve food and how can we store our produced crops, like crops, okay, which are of course food. Okay, some of them will eat them raw, some will have to process or cook them properly, but so far they can serve as food or are edible, then they are food crops. All right, so how can we then preserve and store these food crops, either in their raw state or in their processed forms as finished products? Now, we have many ways, right? Ways of preserving food. We can refrigerate, we can freeze, we can smoke, we can sun dry, we can even irradiate, we can pickle, that's treat with vinegar. Okay, what else? There are so many ways, all right? We can even undergo pasteurization, all right? So, for example, when we get our fish, okay, when we buy our fish from the wet market, if you just left it, of course, the fish will spoil. So you have to what? Dry the fish, or maybe you smoke it. Okay, that way the moisture content will be reduced and it will be preserved, because remember, too much moisture will mean more bacteria or microorganism can grow and destroy or damage or what? Spoil or deteriorate the crop, isn't it? So that's why we do all of these things, to avoid food spoilage, and this will then increase the life, okay, or the it will preserve it, it will make it last and will not deteriorate or spoil. Okay, so that's it. What about milk? If we just got milk from the udders of our farm animals, such as our cows, okay, the udders, of course, you know, are the breasts. So if you just milk this milk from your farm animals, say your cows, and then you just left the milk, of course, in the next 2 hours, go there, the smell is spoiled, it is bad, because the milk has been infested by microorganisms and bringing out bad smells or other foul smells, because due to spoilage. So that's why we need to what? Pasteurize. Okay, we subject this milk to high temperature and pressure, and then we can can them. Okay, put into tins, like you have your peak milk, your tins, isn't it? We can even choose to make them condensed. That's for further storage. Okay, and then what about and of course, all right, so what about which other way? Pickling. Okay, now for pickling, what we do is that we just treat this food crops with what? Vinegar. Okay, for example, vegetables would have just spoiled, or fruits would just spoil if you don't preserve them well, or if you don't store them well, isn't it? But when you pickle, when you treat with vinegar, this vinegar has a way of it's a chemical. Okay, it will just absorb the water that that these microorganisms will leave and destroy the crop. So the vinegar will have a way of preserving it, to become toxic to these microorganisms, so that even the little water content left, of course, in the vegetables and the fruit will be preserved. It will be protected from spoilage by microorganisms, because this vinegar will become toxic to these microorganisms. They won't want to infest the crop or the food crops, such as your fruits and vegetables. So it will then make these fruits and vegetables to actually last longer, okay, before you eat them. All right. Another way would be salting. All right, if you want to preserve your food, even cooked food, we don't just salt for salting's sake. You think we just add salt for what? Yeah, it's to actually, it improves taste, yes, but it's also to preserve. If you just cooked without adding salt, for example, your meat, okay, before you cooked it, all right, of course you have to cook your meat very well, isn't it? All right, but some of us will just buy and then we leave it and then want to do something before we go back to the kitchen to cook. Now, if you really want to do it that way, then you just have to add plenty of salt. It can keep the fish or meat still preserved until you have to come back to cook the meat properly, so that it doesn't spoil. But if you just bought it and then you just left it, okay, even in 1 hour to return to cook, it would have spoiled if you did not add salt. But if you just add salt, then you go and come back within an hour, you discover that the fresh meat is still good to cook, okay, because the salts, okay, have actually preserved it, okay, preventing microorganisms from infesting and making it go bad or foul, producing foul odor. Okay, so aside it, another way is and so on, so forth and so on. We can also irradiate. Passing these crops, passing radiation, X-ray. Okay, but that one is onto the crops to maybe ultraviolet light rays. Okay, to preserve the food, can also irradiate. Okay, but I don't know. You really have to know how to do it properly. Okay, technology is really practiced by technologically advanced countries, and of course you have to put on your protection materials. Your clothing must be well protected to prevent excess rays from getting into your body during the process of this irradiation. All right, so what of storage? Of course, we can store our food crops in barns, such as your yams, your tuber crops, right? Your yams. You can store in tins. All right, you can store them in cans, in silos, like the rice or the grains, and so on and so forth. So we have stored in sacks, okay? And then you place them above the ground. So we have storage cans, and we really have to store our food and properly for preservation purpose, so that they don't go bad. And of course, we don't have to eat anything bad, because it can be damaging to our health and may cause loss of lives if what we eat is not well preserved. It's not well cooked, because the dangerous microorganisms that would have infested these food crops can then, if we take it into our bodies, of course they can damage our tissues and cells, and that could lead to death. So we don't want to take anything that is not well preserved or well stored. So having looked into all of these, the last objective is that you can mention ways that the government have the government of Nigeria, for example, we can mention ways that the government, has helped in the production of more food, or making more food available. What do you think are the ways that the government has helped increase availability of food or food supply? Now, basically, looking into Nigeria, for example, you see that our population is growing way faster than the food supply or the farm produce, isn't it? While like in the note I gave you, we said that while the population is growing geometrically, the food supply is growing or increasing arithmetically. Geometrically, in the order of, say, 3 times 3, 9. 9 times 3, 27. 27 times 3, 81. So 3, 9, 27, 81, in that order. But when we talk about arithmetic progression, it's just going in, say, the odd numbers. 1, 3, 5, 7, like that. 9. 11. So you discover that that is just how it is going. Of course, you see that the gap is very little, like 2, 4, 6, 8, 10. Like 1, 3, 5, 7. You see that? 9, just two spacing, or 3, in between. If it's a geometrical progression, say using 2, giving it from an example of 2. If it's geometric, the way the population is growing, it becomes 2, 4, 8, 16, 32, 2, 2, 4, 6, 8, 10, which is the way our food supply is growing. So you see that the geometrical progression is faster than the arithmetic progression. In other words, our population is growing faster, triple times, whatever we are getting in terms of food production. So there is a need to maximize our food production channels. There's a need for more food, so that we will not run into famine, or as in famine, or get sick of lack of food and die of malnutrition, and so on and so forth. So that is why the government of any nation plays roles to enhance more food supply for her citizens. And some of the ways we will think of, okay, that could help more food supply to be generated in any country would be that if that government, okay, if the government of that country should provide more land for agriculture. Instead of just constructing whatever other things, they could just leave some land, many land actually, for agricultural purposes. Okay? They must not all build all over the land, then we'll not import food. It shouldn't be. Okay? So a way would be leaving or giving large pieces of land for agriculture, giving out to farmers for agriculture. That way, more food will be what? Generated for her populace. What do you think? We have many ways. I gave you many, right? But what do you think can be done? Or what do you think is Nigerian government actually doing? Do you think Nigerian government is doing anything to increase our food supply? Even though our population is growing way faster than the food supply, do you think the government of Nigeria has been able to come up with objectives or ways and are really implementing them to make sure that we don't starve in this nation? It's a food for thought. Or do you think every citizen, okay, do you think we are all having the right portion of food requirement? Do you think we are not malnourished? Do you think we have food, we are all feeding fine, 3 square meals or even more a day? Do you think we are not lacking food in any way in Nigeria? What do you think? All right. So I gave you lots of ways, right? Another way could be that the government of that country will provide soft loans, okay, for the farmers. We provide materials, okay, agricultural seedlings, okay, and fertilizers and so on and so forth, and even machineries, farm machineries, okay, that will help the cultivation and production of food, okay. Another way would be that the roads are well developed such that from the farmland to the market, the road should be accessible so that these farmers can easily what? Bring out their what? Food from their farms and sell to the population. Because if the food is just there in the farm and the road is so bad, so how would the food get to us in the cities and other parts of the country? So there should be a good road network between the rural areas and the urban areas, okay? So that the channels, the food can be well disseminated or distributed for everyone, to everyone's reach in that country. What do you think? That would be good, right? And do you think our roads are good? Do you think the government is really doing good about that? All right, so of course there should be enlightenment to our farmers. Some of them are uneducated. Okay, we can start teaching them. The government can select or pick or employ, okay, individuals that are experts in agriculture to go and train our farmers on ways to improve and produce better qualities of crops and plants and animal breeds, okay, so that we'll have more meat, more milk, and whatever we take in will be more nutritious and will give us the right nutrients for health and longevity. So, are we true? And so on and so forth. I want us to stop here, all right? We've really covered the objectives, and I hope you really learned. So that's just the explanation to the note I gave you. And I hope you read the notes. I hope you play this video and understand what we've discussed and even refer to your textbooks, okay, for more information. Remember, you're a student. You don't just depend on what the teacher is given out to you. You do more research. You check into your textbooks, okay, to get more information for yourself. Thank you. Till we meet again. Bye.